There is one moon in the solar system where taking off your helmet wouldn't kill you through pressure. And that's exactly why it fools so many people. That place is Titan, Saturn's largest moon. Surface pressure there is about 45% higher than Earth's at sea level, so nothing in your lungs would burst, and there'd be none of that dramatic explosive rupture movies love to show. The real problem shows up almost as fast anyway. With no oxygen in that thick orange air, hypoxia starts within seconds, and you'd likely lose consciousness within 1 or 2 minutes, roughly the same window as almost anywhere without breathable air. Temperature hovers around 179 degrees below zero, and because Titan's atmosphere is dense, it pulls heat away from your body through direct contact, something a vacuum simply can't do, which means, ironically, you could actually cool down faster on Titan than floating unprotected in the vacuum of some other moon. There's another detail worth knowing. Gravity on Titan is so low and the air so dense that, with a suit and a simple pair of wings strapped to your arms, a human would have more than enough muscle strength to literally fly by flapping, something no other moon in this list allows. But how long would you actually stay conscious to enjoy that flight? Not long. Just long enough to realize this isn't, by any measure, the most hostile place on the list. The moon closest to us, the one that's lit up your nights your whole life, shows the other side of that coin, pure vacuum. There's no atmosphere here to cushion anything. Holding your breath would be the worst possible move, because the sudden pressure difference can seriously injure your lungs. They don't explode, but the tissue can rupture internally if the air inside doesn't escape freely. Exposed fluids in your body start forming vapor bubbles under the skin and in your eyes, an effect called ebulism, nothing like water boiling in a pot. You'd lose consciousness within 10 to 15 seconds from lack of oxygen in your blood, and death would follow shortly after, a shorter window than a single TV commercial break. During the day, the lunar surface climbs above 120 degrees. At night, it plunges below -170. But in a vacuum, your body loses heat mostly through radiation, a slow process. So neither the extreme heat nor the extreme cold would have time to matter. Lack of air would kill you first, well before either one caught up. Much farther out, orbiting Mars, sit Phobos and Deimos, 2 moons so small they barely deserve the name. The physiological sequence there would be nearly identical to the moon's. Vacuum, hypoxia, seconds of consciousness. What's different is the gravity, almost non-existent. A normal jump on Earth would launch you clear off the surface, floating for minutes before falling back down. If you didn't escape the moon's gravity entirely, walking normally would be impossible, and any sudden step could send you flying straight into space with no way back. These 2 moons probably weren't even born alongside Mars. Many scientists believe they were asteroids captured by the planet's gravity billions of years ago. Before we keep going, this is the right moment to hit subscribe. What's coming next raises the danger level far too much for you to miss it. Callisto, one of Jupiter's moons, looks frozen and lifeless at first glance, covered in craters that piled up over billions of years with no geological activity to erase them. The first threat is, again, vacuum. The same 10 to 15 seconds of consciousness. The same sequence as always. Callisto's difference only shows up if you had a pressurized suit protecting you from the vacuum. In that scenario, radiation from Jupiter would become the deciding factor, even though Callisto receives the smallest dose among Jupiter's major moons, being the farthest out. Even protected prolonged exposure to that radiation would seriously damage your body within a few hours. Callisto's most visible scar is an impact basin over 3,000 kilometers wide, formed by a collision so violent it reshaped part of the moon's icy crust. We still study craters like this one to understand what the solar system's first billion years were actually made of. But Callisto is the calmest of Jupiter's moons. The same can't be said for the next stop. Europa hides beneath an ice crust that can run up to 30 kilometers thick, a salty ocean holding more liquid water than all of Earth's oceans combined. Without a suit, vacuum remains the immediate problem. The same seconds-long blackout, the same sequence as always, regardless of any other danger nearby. It's only if you picture someone protected from decompression, breathing normally inside a pressurized suit, that Jupiter's radiation steps in as the real threat. And there it's strong enough to build up, within a few hours, a dose equivalent to thousands of X-rays taken all at once. The correct order, then, is vacuum first, hypoxia right after, and only then radiation, assuming there's some protection against everything else. In Europa's low gravity, a normal jump would send you several times higher than on Earth. One more curious detail hiding behind a lethal environment. Beneath the ice, geysers of water vapor escape into space, feeding the suspicion that something alive might be hiding down there. But to reach that possible life, you'd have to cross exactly the environment that would kill any human being in under a minute. Ganymede is the largest moon in the solar system, bigger even than the planet Mercury. It's also the only known moon with its own magnetic field, generated by a molten iron core inside it. Without a suit, the outcome is the same as always. Vacuum, hypoxia, a few seconds. But that magnetic field deflects part of Jupiter's radiation. So, for someone protected from decompression, the second threat would take a bit longer to turn critical than on Europa or Callisto. Not relief, just a small delay. Gravity on Ganymede is low enough to make walking feel strangely light, almost like a continuous bounce with every step, yet still recognizable as walking. The surface mixes ancient, crater-covered regions with younger grooved terrain that suggests tectonic activity sometime in the past. And that small delay runs out fast at the next stop on the list. Enceladus is small, icy, and surprisingly active, but only in specific spots. Near its south pole, geysers shoot columns of water vapor and ice particles hundreds of kilometers into space, fed by a subsurface ocean warmed by Saturn's gravitational pull. That doesn't cover the whole moon. Across most of the surface, the scenario is the usual one. Vacuum and hypoxia within seconds, no extra surprises. The surprise is reserved for anyone standing near one of those geysers at the exact moment it erupts. There, you'd be hit by ice and vapor launched at speeds that outpace many commercial jets in flight. A mechanical risk, not a thermal one. Surface temperature sits around minus 201 degrees, among the coldest ever recorded on a solid body in the solar system. But again, in a vacuum, that cold simply wouldn't have time to act before the lack of air did. It's precisely that hidden ocean beneath the ice, shielded from the surface's vacuum, that makes Enceladus one of the most interesting targets in the search for microbial life beyond Earth. Triton, Neptune's largest moon, holds one of the coldest records ever measured on any body in the solar system, around minus 235 degrees at the surface. That's cold enough to freeze nitrogen solid, coating much of the moon in frozen gas. Even so, vacuum remains the threat that arrives first. In space, with no air to conduct or circulate heat, the body loses temperature mostly through radiation, a process far slower than most people imagine. That means even somewhere as extreme as Triton, lack of oxygen still wins the race against the cold. Its retrograde orbit, moving opposite to Neptune's rotation, is a strong clue that Triton wasn't born there. It was likely captured from the Kuiper Belt, the same icy region Pluto comes from. Ice volcanoes, called cryovolcanoes, spew liquid nitrogen and other frozen compounds into the moon's thin atmosphere. And even after all that, something worse is still waiting. Io is the most volcanically active moon in the entire solar system, with hundreds of volcanoes erupting constantly, some throwing material more than 400 kilometers into the sky. Without any protection, vacuum kills the same way it always does, in seconds. Io's real difference shows up for anyone wearing a suit. It orbits inside the most intense region of Jupiter's radiation belts, delivering a dose so high that a person inside an ordinary spacesuit would suffer serious damage within minutes, and a fatal dose within a few hours. The shortest window in this entire list for any secondary threat beyond decompression. Io's low gravity would also make your body feel noticeably lighter, turning every movement oddly easy despite the radioactive chaos around you. The surface is coated in sulfur, which explains the yellow, orange, and red hues visible even through telescopes on Earth. Probes that flew near Io had to be built specifically to withstand radiation levels capable of frying ordinary electronics within just a few hours of exposure. No other moon in the solar system combines such extreme volcanism with such a hostile radiation environment at the same time. Miranda, one of Uranus's moons, closes out this list without changing the basic physiology. Vacuum, hypoxia, a few seconds, just like almost everywhere else. What changes is the scenery around your body while it happens. Miranda holds the tallest cliff ever identified in the solar system, roughly 20 kilometers high, more than twice the height of Mount Everest. In the moon's nearly non-existent gravity, a fall from up there would take several minutes before you hit the ground. Except, since the vacuum would have already done its work well before that, you'd fall unconscious, never actually feeling the final impact. The surface is a chaotic mix of ancient, crater-covered regions, next to completely smooth, younger bands, as if different parts of the moon had lived entirely different histories. Nobody knows with total certainty what force was able to tear apart and reassemble Miranda's surface like that. A near-catastrophic impact or internal tidal forces generated by Uranus's pull are the two leading suspects. But what actually matters for your body in the end is simpler than the geological origin story. Nowhere on this list, except Titan, would you get more than a minute or two of consciousness before the environment finished the job on its own. If you enjoyed finding out exactly how long your body would last in every frozen corner of the solar system, subscribe to the channel, drop a like, and tell me in the comments which one of these moons surprised you the most.